question involves a motion sensor controlling soffit and lights through a definite purpose contactor where the motion sensor causes contactor chatter. Adding an incandescent lamp across the coil resolves the issue. Several potential solutions exist to eliminate this problem. Firstly, consider adding a capacitor, typically 0.1 to 1 microfarad, in parallel with the coil. This provides a temporary surge of current to help the contactor pull in. Secondly, install a snubber circuit. A snubber circuit consists of a resistor between 100 and 250 ohms and a capacitor 0.1 to 1 microfarad in series across the coil. The resistor limits the current surge, while the capacitor provides a discharge path for the coil's energy. Thirdly, connect a diode in parallel with the coil with the anode to the positive terminal. This allows current to flow in one direction only, preventing reverse current flow that can cause chattering. Fourthly, install a coil suppression module. A coil suppression module is a specialized device designed to eliminate chattering in magnetic coils, and it typically uses a varistor or other components to suppress voltage spikes. Always use caution when modifying the wiring, as incorrect connections can damage the contactor or other components. Ensure that the capacitor or snubber circuit is rated for the voltage and current of the contactor's coil. If the problem persists, there may be a fault with the motion sensor or the contactor itself, and further troubleshooting is necessary. When selecting a capacitor, ensure it's rated for the appropriate alternating current voltage. Common voltage ratings are 120 volts alternating current, 240 volts alternating current, or higher, depending on the contactor coil voltage. The capacitance value, typically between 0.1 and 1 microfarad, is crucial for providing the necessary surge current without causing damage. A snubber circuit is more sophisticated than just a capacitor. The resistor in series with the capacitor dampens oscillations and limits the current surge. This prevents the capacitor from being overloaded and reduces electromagnetic interference. Typical resistor values range from 100 to 250 ohms, with a wattage rated of at least 0.5 watts, but higher ratings might be needed depending on the application. The capacitor in the snubber circuit should also be rated for the appropriate alternating current voltage and have a capacitance value between 0.1 and 1 microfarad. When using a diode, select one with a voltage rating at least twice the peak voltage of the alternating current supply and a current rating sufficient to handle the coil's inrush current. A common diode for this purpose is a 1M4007 or similar rectifier diode. Orient the diode correctly, with the anode connected to the more positive side of the alternating current supply and the cathode to the more negative side. For coil suppression modules, choose a module specifically designed for use with contactor coils. These modules typically include a varistor or other voltage clamping components to suppress voltage spikes. Ensure the module is compatible with the contactor's coil voltage and current. Review the contactor's specifications to determine the appropriate suppression module. If the motion sensor is not providing sufficient voltage or current to reliably activate the contactor, it may be necessary to use an interposing relay. An interposing relay is a small relay that is controlled by the motion sensor and in turn controls the contactor. This isolates the motion sensor from the high current demands of the contactor coil. When wiring the circuit, use appropriately sized conductors and connectors. Follow the National Electrical Code (NEC) guidelines for wire sizing and overcurrent protection. Ensure all connections are secure and properly insulated to prevent shorts and other hazards. If the contactor is located outdoors or in a damp environment, use a weatherproof enclosure to protect it from the elements. This will prevent corrosion and other damage that could lead to malfunctions. When working with electrical circuits, always de-energize the circuit before making any connections or modifications. Use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical circuits, consult a qualified electrician. Contactor chatter can also be caused by mechanical issues with the contactor itself. Check the contactor for loose parts, worn contacts, or other damage. If the contactor is damaged, it may need to be replaced. Also, ensure that the contactor is properly mounted and aligned. Misalignment can cause the contactor to vibrate and chatter. The type of load being controlled by the contactor can also affect its performance. If the load is highly inductive, it can generate voltage spikes that cause the contactor to chatter. In this case, a snubber circuit or coil suppression module may be particularly effective. If the problem persists, it may be necessary to use a different type of contactor or a solid-state relay. Solid-state relays are less susceptible to chatter than electromechanical contactors. When troubleshooting electrical problems, it is important to have a systematic approach. Start by checking the simplest things first, such as the wiring connections and the voltage supply. Then, gradually move on to more complex components, such as the motion sensor and a contactor. If you are unsure about any aspect of the troubleshooting process, consult a qualified electrician. Always follow safety precautions when working with electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Work in a well-lit area and avoid distractions. If you are working on a ladder, make sure it is stable and properly positioned. If you are working outdoors, be aware of the weather conditions and take precautions to protect yourself from the elements. Contactor chatter is a common problem in electrical circuits, but it can usually be resolved with a few simple troubleshooting steps and the appropriate solutions. By understanding the causes of contactor chatter and the available remedies, you can effectively address this issue and ensure the reliable operation of your electrical system. Remember to always prioritize safety when working with electricity. If you are not comfortable performing any of the troubleshooting steps or solutions described, consult a qualified electrician. They have the knowledge and experience to safely and effectively resolve electrical problems. In addition to the solutions mentioned earlier, consider the quality of the power supply. Voltage fluctuations or surges can cause contactor chatter. A power conditioner or surge suppressor can help stabilize the voltage and prevent these issues. Also, check the wiring for any loose connections or corrosion. Loose connections can cause voltage drops and intermittent contact, leading to chatter. Clean and tighten any corroded connections. Furthermore, consider the ambient temperature. Extreme temperatures can affect the performance of electrical components. Ensure the contactor is operating within its specified temperature range. If the temperature is too high, provide ventilation or cooling. If it's too low, consider using a heating element. The motion sensor sensitivity setting can also contribute to the problem. If the sensitivity is set too high, the sensor may be triggered by minor movements or electrical noise, causing the contactor to chatter. Adjust the sensitivity setting to a lower level. If the motion sensor has a time delay setting, adjust it to prevent the contactor from repeatedly cycling on and off. A longer time delay can help stabilize the circuit. If the load being controlled by the contactor is frequently switched on and off, it can cause excessive wear and tear on the contactor. Consider using a soft starter or variable frequency drive, volts per hertz, to reduce the stress on the contactor. These devices gradually increase the voltage applied to the load, reducing the inrush current and preventing voltage spikes. Another factor to consider is the type of wire used in the circuit. Aluminum wire can corrode over time, leading to loose connections and voltage drops. If you suspect that aluminum wire is the cause of the problem, replace it with copper wire. Copper wire is more resistant to corrosion and provides a more reliable connection. When replacing wiring, use the correct gauge wire for the load being controlled. Undersized wire can overheat and cause voltage drops. Consult the National Electrical Code (NEC) for wire sizing guidelines. Ensure that the circuit breaker or fuse protecting the circuit is properly sized. An undersized breaker can trip prematurely, while an oversized breaker may not provide adequate protection. The breaker should be sized according to the ampacity of the wire and the rating of the load. In addition to the solutions mentioned, consider using a programmable logic controller (PLC) to control the contactor. A programmable logic controller provides more flexibility and control over the circuit. It can be programmed to implement complex logic functions and prevent contactor chatter. Programmable logic controllers are commonly used in industrial applications where precise control is required. When installing a new contactor, choose a model that is specifically designed for the application. Some contactors are designed for heavy-duty use, while others are designed for lighter loads. Select a contactor that is rated for the voltage, current, and duty cycle of the load being controlled. Also, consider the contactor's enclosure rating. If the contactor is located outdoors or in a damp environment, choose a model with an M4 or an M4X enclosure rating. These enclosures are designed to protect the contactor from water, dust, and other contaminants. Regular maintenance can help prevent contactor chatter and other electrical problems. Inspect the wiring, connections, and components on a regular basis. Clean any dirt or corrosion from the connections. Tighten any loose screws or bolts. Replace any worn or damaged components. By following these maintenance practices, you can extend the life of your electrical system and prevent costly repairs. Furthermore, documenting all changes made to the electrical system is crucial for future troubleshooting. Keep a detailed record of all wiring modifications, component replacements, and settings adjustments. This documentation will help you quickly identify and resolve problems in the future. When working with electrical circuits, always use the proper tools and equipment. Use insulated screwdrivers, pliers, and wire strippers. Wear safety glasses and insulated gloves. Work in a well-lit area and avoid distractions. If you are unsure about any aspect of the electrical work, consult a qualified electrician. They have the knowledge and experience to safely and effectively perform electrical repairs. If the contactor chatter is intermittent, it can be more difficult to diagnose the cause. In this case, it may be necessary to use a data logger to monitor the voltage, current, and other parameters of the circuit over time. A data logger can help identify transient events that may be causing the chatter. The data logger should be connected to the circuit at a point close to the contactor. This will provide the most accurate data. Once the data has been collected, it can be analyzed to identify the cause of the chatter. For example, if the voltage is fluctuating rapidly, it may indicate a problem with the power supply. If the current is spiking, it may indicate a problem with the load. The data logger can also be used to monitor the temperature of the contactor. If the contactor is overheating, it may indicate a problem with the cooling system or the load. The data logger should be set to record data at a high sampling rate. This will ensure that all transient events are captured. The data should be stored in a format that can be easily analyzed, such as a comma-separated value (CSV) file. There are many different types of data loggers available. Choose a model that is appropriate for the application. Some data loggers are designed for monitoring voltage, while others are designed for monitoring current, temperature, or other parameters. Some data loggers are wireless, which makes them easier to install and use. After implementing any of these solutions, thoroughly test the system to ensure the contactor chatter has been eliminated and the system operates reliably under various conditions. Monitor the system for any signs of overheating, unusual noises, or other abnormalities. If any issues arise, re-evaluate the solutions and consult a qualified electrician for further assistance.